This video is for educational and scientific purposes only. I do not tend to defame any brand, nor I have been sponsored by Coca-Cola or any other brand as such. So over here I have a bottle of Coca-Cola, and when I see the ingredient list, it says it had acidity regulator 338. So I searched on Google to find what is acidity regulator 338. So I got this on Google. So you can see that there is a FSCI mark also on this bottle, and when I saw the information list, nowhere it mentions of phosphorus. So to find out how much phosphoric acid is present inside this, I took out 500 ml of Coca-Cola with a 100 ml measuring cylinder. So I have to measure 100 ml Coca-Cola 5 times, and I poured this into a 1 liter beaker. Now to it I added some ammonium chloride and swirled it to dissolve it. Then I will add some ammonium hydroxide. To ammonium chloride is added to buffer the solution, and the method that I will use here is the gravimetric precipitation of zinc ammonium phosphate. So for that I'll be adding some ammonium hydroxide. So first I added 20 ml of ammonium hydroxide. This is dilute ammonium hydroxide, and then to it I added zinc chloride solution. On adding zinc chloride, zinc ammonium phosphate should be precipitated out. But what happens here is some zinc hydroxide is also being precipitated, and when I added some additional ammonia, the zinc ammonium phosphate also gets dissolved. So this precipitation is not very reliable for phosphate, as the precipitate is soluble at high pH due to the complexation of zinc ions with ammonia, and also due to the precipitation of zinc hydroxide at a lower pH. This method cannot be used to quantitatively measure the amount of phosphate. So now I will be relying on a different method, which is the magnesium ammonium phosphate precipitation method. For that I dissolved some magnesium sulfate and ammonium chloride in some distilled water and took out 200 ml of Coca-Cola in another beaker. After the ammonium chloride and magnesium sulfate has been dissolved, to the solution I added some ammonium hydroxide, and you can see that no precipitation has occurred. This is because ammonium chloride acts as a buffer and does not let the pH go high so that magnesium hydroxide can be precipitated. Now on adding this solution into this Coca-Cola, the phosphate is getting precipitated in the form of magnesium ammonium phosphate. You can see that a crystalline precipitate is formed, and this precipitate is not soluble at high pH, so we can rely on the magnesium ammonium phosphate method. Now we have to digest the precipitate. So to digest the precipitate, I placed both the beakers on a boiling water bath and then cooled them. By this method we digest the PPT. So what happens in digestion, that the small particles coagulate to form bigger particles. Now both the precipitates were filtered by a sintered glass crucible which was pre-weighed. You can see these are the reactions of the precipitation method that I have used. So this is the precipitate of zinc ammonium phosphate, which was dried in an oven until the weight becomes constant, and it measures out to be 0.56 grams. So the phosphoric acid according to this could be 615 ppm. But as I told you, I could not relax, so I washed this crucible with concentrated hydrochloric acid, and then again I filtered the magnesium ammonium precipitate with this. Then I washed the precipitate with distilled water, and then again place the crucible in a desiccator to dry until the weight becomes constant. We cannot dry this precipitate in oven because this precipitate contains water of crystallization which could be lost in due to high heat of the oven. So I dried this crucible in a desiccator, and then when its weight become constant, which became constant at 31.2 gram, I did all my calculations. You can see on the screen right now. So the phosphoric acid content came out to be 659 ppm or milligram per liter. To wash the crucible, some concentrated hydrochloric acid is added inside the crucible and left for some time. Over the time, the precipitate will get dissolved in hydrochloric acid and our crucible will be cleaned in this way. Please rate, comment, and subscribe. You can also support me financially through PayPal. Links are given in the description.